Hello, MA250. We're Team 8, Team Multigrain Bread. I'm Kevin Liu.
I'm Fausto Patino.
I'm Abdo Time Jardine Zomenio.
I'm Fadi Al Swais, and we are here to present you with the epic, cool Spooky Box.
For our problem statement, our team was asked to make a box with one side that will be able to open and close without any human intervention. All parts must be securely attached to the box and should be made out of materials that could be located at home. Objectives are things the team wants the design to be or look like. An objective tree was made to list all objectives as well as sub-objectives, and as you see, the farther you go down the tree, the more specific the objectives get. Our main four objectives were easy to produce, efficiency, entertaining, and safety. Our constraint lists are rules and parameters the team has to follow and work with in order to make a satisfactory product. Our main constraints relate to opening the box without direct intervention with a safe and secure manner. Our metrics are located at the bottom of the objective tree and is how we intend to measure our objectives. Each sub-objective has units that the team can measure, such as affordability in dollars, our fast opening speed in seconds, fun index on a 1 through 5 rating, 1 being the lowest, 5 being the greatest, and how eco-friendly it is in kilojoules.
Okay, so now we get into our function means tree. And what this basically does is this allows the team to put together a list of the objectives and the means for those objectives and put it into a sort of graphical interpretation so that the team is able to look further into what different combinations, what different designs they can use in order to make the epic cool box. And it also allows for the team to better decide and split between what kind of devices they have, whether it's mechanical, physical, things of that nature. Next, we get into the morph chart. So after we've finished making the function means tree, we then take all of the objectives and the means by which those objectives are executed, and we put them into a more fixed Excel sheet in this way. So as you can see, we have them listed by function and what each means does. So then we put each one together side by side this way so that we're able to come up with all of the possible combinations in order to see what we want to go with by the end. And what's nice about the Excel sheet is that it actually calculates all of the possible, auto-calculates all of the possible different ways that you can put together the epic cool box and what parts you want to use. And so for this tree, this function means tree and this morph charts in specifics, we were able to come up with 4,128,768 possible combinations for making the epic cool box. And then after we make the morph chart, we then get into the reduced morph chart. So what that is, we get into going through the entire morph chart and we sort of look at what types of possible combinations don't logistically really make sense to put together, or what may not mechanically function if put together, because we want to be sure that the epic cool box does the primary function, which is to open and close without any human assistance of any kind. So what the reduced morph chart helps us to do is we're able to go into the first morph chart, see what happens if any of the parts don't make sense to put together. We remove them and then we go from there. So it also helps the team to get a better understanding of what different function and their means would go together and which ones don't. So by the end of this one, we were able to find out that we have 11,520 possible combinations for making the Epic Cool box.
So for the top 5 concepts, we have concept number 1. It's a mechanical device with a crank and a string. It works off the crank winding and unwinding the string to open and close the box. Then we have concept number 4. It's a mechanical device with a lever and a spring. It relies on restoring the force to the spring when the lever compresses or extends it to open and close the box. Then we have concept number 5. It's an Arduino device with a servo motor and an ultrasonic sensor. The concept relies on the sensor detecting the user's proximity that is connected to the Arduino device that's connected to the motor that will open and close the box depending where the user is standing. Then we have concept number 7. It's an Arduino device with a servo motor, a button, and a string. It's very similar to concept number 1. The difference is this one will use a push of a button to open and close the box because the button is connected to the Arduino device that's connected to the motor that will then open the box. Then we have concept number 17. It's an Arduino device with a DC motor and a light sensor. The concept works with the light sensor. By covering the sensor and decreasing the light, it will close. By increasing the light, either could be artificial or natural light, the box will open. So for the comparison, we used affordability, size fits object, durability, creativity, safety, and eco-friendly. For affordability, the Arduino devices had better affordability since they were given to each student on the beginning of the project. Then we have size fits object. The servo motor was more suitable because it has less components than the mechanical devices, meaning they can fit inside the box, easy, not complicated, and also this way they don't have to show from outside. Then we have durability. Durability means how many times can we keep opening and closing the box without it breaking? And the Arduino devices had better durability than the mechanical ones. And for creativity, number 5 was the most creative since everything was inside the box and also nobody knows how it works until you're close to it. Then we have safety. For safety, concept number 17 was the lowest in safety rating because there was a risk of getting splinters on your fingers from the box itself. And concept number 5 was the safest because it was made of cardboard, also because it didn't require any intervention. It would do everything on its own. And for eco-friendly, in general, the Arduino devices were the most eco-friendly that did not require any power that would damage the environment or damage the surroundings of the box.
All right, and now on to our top designs. In third place, we have concept number 7 with all the components listed on the left. Here in this design, you would press this button attached to the Arduino that would then in turn turn the servo motor attached to the string that would wind to either lift open the box and would unwind to let more string out and therefore close the box. And then here we have concept number 17, also an Arduino device. And here we would use a DC motor attached to the Arduino, and here's the arm. And by activation, we have a light sensor. So by either covering the light sensor or by applying more light to the light sensor, it would detect the difference in light and would therefore turn the DC motor attached to the arm to prop open the lid. Here in concept number 5, our winning design, we put everything inside the box to add more to that surprise and that fun factor for the user. And you'll be able to see here in our CAD model that we have everything. Let's see here, the ultrasonic sensor, all of our components inside, along with our servo motor attached to an arm. So this plan works by an ultrasonic sensor detecting the user's proximity, which would then go through the Arduino and everything to open the servo motor that attached to an arm to open the lid. Once again, we're Team 8, Team Multigrain Bread.
Thank you for your time, and we would like to tell you
Happy Halloween!
Happy Halloween!